It's likely that almost all of us are familiar with an igloo. The almost cartoony hut built of bricks of ice and snow, usually depicted as the home of some fictional penguin in the middle of a wide barren landscape. It may be a familiar sight, but what about the real life igloos? Where were these built? Will not be too cold? Let's look a bit deeper. The main reason the igloos were used is their surprising warmth for a structure made of ice. The outside of the igloo often reaches temperatures as low as -45 degrees Celsius, but the inside can reach 16 degrees. That's better than the alternative. The igloo is able to keep these temperatures by trapping the body heat released from your body inside the igloo. But how does it stay this temperature? Firstly, the structure. A good way to look at how the heat is trapped in the igloo is to look at the diagram. Looking at it, you can see that the entrance of the igloo is underneath the ground. This takes advantage of the simple principle that heat rises as it is less denser than cold air. All the cold air in the entrance gets trapped within the low chamber, alongside any of the cold air within the actual igloo, which is pushed out by the warm air. As hot air is less dense than cold air, the hot air will flow over the cold air and stay inside the main igloo structure, keeping it warm inside. You may have wondered why igloos don't just melt from the fire or the sun's rays. One very important characteristic of the snow used to make the igloo is its heat capacity of 290 joules per kg per Kelvin. This means that it takes a lot of heat energy to heat it up enough to melt it. Also, it releases any heat it absorbs very slowly, which prevents heat loss to surroundings. This is due to acid structure, as it is a structure of crystals with air pockets between each crystal. These air pockets trap any heat inside of them, not allowing it to escape. This means that the ice blocks will absorb a lot of heat before any of it is released as any energy, stopping any changes in state. The walls are also extremely thick, not allowing any cold generated by the harsh winds on the exterior to penetrate through to the inside. Again, the igloo stays warm as the temperature is not altered significantly from the winds. The sun emits infrared electromagnetic rays which heat up surfaces. As the igloo is white, it reflects the rays off, preventing the exterior from melting. Other practices are used to combat melting, like lining the indoor walls with animal skin. Additionally, the small amount of melting snow on the inside will freeze, creating a layer of ice as it refreezes. This adds reinforcement to any threat of collapsing and to further raise the heat capacity. These allow for some larger igloos to contain fires, further raising the temperature within.